So I've always been interested in computer graphics programming, and so in the course of last year I took C++, and I've been able to do a few projects, and this is one of them, which is a quicksort algorithm visualizer that I wrote in C++ in a library called SFML. So let me just run the program so you can see it in practice. Quicksort algorithm uses a technique called divide and conquer, and before it even finishes, let me show you how it works. So this is how the quicksort algorithm works. So for example, you have an array here, the array of items. So we need the low, which is the index of the first element, which is always 0. And then you also have high, or the pivot, which could be any other number, but then we prefer taking the last item. Depending on the programming language you're using, in C++ is array.size minus 1. So the array.size gives you the total the number of elements in this array, and then minus 1 to give you the index of the last item. And then so we have the pivot, and then we have this item. So it divides these numbers based on whether they are larger than the pivot or smaller than the pivot. So all the numbers that are smaller than the pivot are moved to the left, and those that are larger than the pivot remains in their positions. And then after all the numbers that are smaller than the pivot have been moved to the left, the pivot is moved to the last index of the numbers on the left. And now that will be the new pivot, and it continues that way recursively until the entire array has been sorted from the smallest to the largest. So that is how the quicksort algorithm works. Now let's go back to the visualization. So the first visualization, I just used the random number, the random bars, but then the second visualization I added numbers there so that you can see the numbers on top of the bars. So let's see the first implementation, where it is now. You can see this is the pivot. The red is the pivot, and you can see it keeps doing the same thing, okay, until the entire array is sorted. So that is what we call the recursive implementation. So it uses a technique called divide and conquer. And then you can see that everything is sorted. So this was the implementation with only bars. So let me just add there. Let me just run the implementation where now we have the numbers on top of the bars. So you can see now I just add a number so that you can see the numbers in real time. You can see how the numbers are being moved. The smaller than the pivot are moved to the left, and then the larger one remain on their position. And then once the lefters have been sorted, it again moves the pivot. It keeps moving the pivot. And there you go, it does that until the array has been sorted from the smallest to the largest. You can see the largest is 98. Yeah.